Section 8.2 is the z-test for a mean. But in this chapter, two statistical tests will be explained. The z-test when sigma is known, and you can probably guess what's coming next, and the t-test when sigma is unknown. I'm on page 419, but going fairly quickly on over to page 420. And on 420, you're going to see the z-test, and you're going to see this formula. And so if you don't already have out your note paper, your sticky notes, your highlighters, your everything, make sure you do have out your formula card, and we are in Chapter 8. And when you look at Chapter 8 on our formula card, right here is the same thing that we're looking at. The z-test, x bar minus mu divided by sigma divided by the square root of n. And that's for any value of n, with a clause. If it happens to be less than 30, then the population must be normally distributed. We're going to be safe for this textbook, but that's something to highlight for a future course. Many of you may want to go ahead and get your master's, and you may need to take an additional statistics course. And this would be a great formula card or book to hang on to if you have any leaning of going that direction, or just to keep it just in case. Having said that, you've got the formula for the z-test, and then right here. I know that I've already mentioned to you in a video that on your formula card you have this procedure table. And we went through these steps, and then what we're going to end up doing is on page 417, we're going to be coming back to the chart. And on the chart, that's where we're going to make our final conclusion of what's going on with our hypothesis test. I come back to this, and I know I've already asked you to watch a video and you've gone through this, but I'd like to show you and get you to underline. I've underlined in black how it will appear on our test. The test is going to give a paragraph, like you see down at the bottom, that's going to have the details of the situation. And then you will need to walk through, and it's a pretty lengthy process, so you're going to need to make sure you're really secure on each part. But you need to know that I will ask on the test for the hypotheses, and I will ask for you to identify the claim. I will ask for the critical value or values, and then I will ask for the test value. I will then ask for your decision, which will be a sentence, and it's going to be a sentence like we will or we will not reject, and the why. And then you'll finish up by saying, knowing this decision, our conclusion is, and then you will have your page 417 statement that you've already put somewhere on this formula card, that you will come back to write your statement, which will include specific details for your question, your problem. I've already asked you to watch a video. I've already asked you to do example 8-3, but I wanted us together, because this is such a lengthy process, I wanted us together to go through two examples. So I'm on page 421, and I'm looking at 8-4, the SAT tests. For a specific year, the average score on the SAT math score was, and here's the average score. The variable is normally distributed. They've got to tell us that for all of us to work. And the population standard deviation, we have sigma. A school superintendent wishes to see if her students scored significantly below the national average on the test. The national average is 515. She randomly selected 36, there's our N, student scores, and as you see them here, and that she wants the alpha to be at 0.10, 10%. Is there enough evidence to support her claim? So I wanted to go ahead and look at these, because as you can see, they do not hand us X bar. We would need to calculate it, but we are going to be lazy and just use theirs. But remember, just a second ago, I said on the test, you're going to have all of these parts to complete. So here we go. I will ask what are the hypotheses and which one is the claim. And so I hope you have gathered, picked up, heard, noticed that our null hypothesis is always going to be the equal 1. And so the null hypothesis is that our mu, our population mean, is this 515. Okay. But you also have to state the alternative hypothesis is that mu is not 515, but specifically this superintendent thinks that they are below. And with that in mind, we'll say that we think that our mu is actually below the 515, and that is the claim. These two pieces of information and the claim are what will get you full credit for hypotheses and claim. Now we need to calculate a critical value. So I'm on page 422. And at the top of 422 it says let's find that. Since we know our alpha, and since it's going to be a left-tailed, well, shame on me, I haven't drawn it yet. So let me draw this. And all I know to draw right now is that we believe that somewhere there is an average. I'm going to cover that up. Somewhere there is an average. Somewhere there's a number, somewhere there... Anyway, let me cover that up. The drawing does say that we think, or that we have proposed, or that in this one it is not a one, it is a one-tail, it's not a two-tail, and specifically it is the less than two-tail, that this area over here is going to be our critical area, or critical region. So with that in mind, I need to find the critical values. I do know it's a left-tailed, I should be drawing, I should be looking, but right up here it says, we're trying to do this at 0.10, it's left-tailed, and the critical value is. Okay, wait and whoa. So they're giving us a lot of stuff, they're working it out for us. You're not going to have all of this on the test. You're going to need to go pick out stuff. And so critical value, oh, I hate it when I write over the words. Critical value is what we are going to go look for. So going to look for the critical value, I got to know all this in my mind. And so maybe I don't have it all like da-da-da-da-da-da-da, but I do know my critical value is Z. And with my critical value being Z, I'm trying to cover up stuff and leave stuff showing and not spoil any surprises here. So I'm going to go to my formula card. And on my formula card, I'm going to go here that because we do have our population standard deviation, I'm going to use a z-test. And with that in mind, I'm even going to copy down, I need x bar minus my population mean. I need my sigma divided by the square root of n. Right here, I already hit a little roadblock, my x bar. They didn't hand it to us, and so I officially need to go add all of these up, and I need to divide all of these, the sum, by 36. Well, here goes lazy. They already added them all up. They got 18,325 to divide by the 36. We get this as our x bar, 509.0, and they put it in as a 3. Oh, they did 2.8 and I did 3. Well, let's see what happens. So I put it in, I rounded it to 0.03, minus my mu, minus this population mean. And when I go back over here, the national mean is 515. So I go back to my formula, and in place of the population mean, I'm going to put 515. I'm going to divide that by my sigma. They told us over here in the problem, they said over here the standard deviation for the population, my sigma, is 100. So I go right here, and I put 100 in for my population standard deviation. I will divide it by the square root of the n, and we already know that our n is 36. I'm going to put all of this in my calculator, and I came up with about point, I already got a negative there, which that's good, because this is going to turn into a negative. I punch all of this in, I get my negative 0.3582. We differed on some of the numbers, like they kept this 0.028. I went ahead and rounded. I should have kept it at 0.028. But they come up with negative 0.36. When I round mine, I get a negative 0.36. So we do match. I just shouldn't have done that. I should have kept it at the 0.028. Anyway, back to what we're doing. So on the test, you will be asked to find the critical value or values. And so the critical value, y'all, I'm so sorry. I'm jumping around all over the place. I found the test. I need to go back over here. Where are we? I'm sorry I'm jumping around. I'm not going to go redo the video part of this, but I need to go clarify. Let me go back over here. I'm trying to rush just like in class, and this is what happens. Backing up, hypotheses and the claim. The hypotheses and the claim for this problem that we are looking at is that, and remember that the null hypothesis is always going to get the equals, that our population mean really is 515. But the superintendent says that they think that their students may be less than that, and so we designate that as the claim. The next thing we're supposed to look at are the critical values. The critical value is that dividing line between the critical region and the rejection region. We looked at that earlier. I'm not going to turn back. I just want to say the critical value is going to be that one value. That one value is the one I glossed over a while ago, jumping down here to get my drawing. The critical value, since we are at the alpha of 10%, and that it's left-tailed, it's one tail. Sorry, I should have jumped over to my table. The one I like is table F. And I should have jumped to table F, and I should have gone to one tail, and right here at my 10%, which is what we have, which is what we have, which is what, not the 80, the one tail, the alpha is 0.10. I'm going to scroll, go all the way down to the bottom, and now I have my critical value of 1.28. The 1.28 is what they have here, but notice they have a negative. That's where I'm going to move part of my little piece of paper. My critical value, the dividing line between the rejection region and the non-rejection region, is negative. I have to put the negative because I'm on the left-hand side. I'm left-tailed. I now have my critical value. I have my critical region, which is my rejection region, and my non-critical or my non-rejection region. Now that I have those on my graph, I now need to go compute the test value. What I mentioned to you earlier is on the test, you'll have to state the hypotheses and the claim. You'll have to state the critical value or values if it's two-tailed. And then you got to compute the test value. We've already computed it. I did it early and jumped over the critical value. So the test value is all of our data. How does it pop out as a z-score? All of our data. How does it? All of our data. And when we do all of our data, it pops out as a z-score of negative 0.36. Negative 0.36. I'm going to go put that on my graph. Remember, if we're going on z-scores, then what's right in the middle is 0. And so this negative 0.36 is somewhere to the left of 0, but it is not over here in our critical region beyond the negative 1.28. So this test value falls in not a critical region. We have talked about the hypotheses and the claim. We have labeled it. We found the critical value, skipped over it, and came back and found it. Then we found the test value, and now we got to make a decision. Do we reject or do we not reject the null hypothesis? And we have to state a sentence. That decision is based on where did our test value fall. Did it fall in the bad lands or did it fall in the safe lands? And so to make that decision on the null, we're going right back over here. Did our test value of negative 3600ths, did it fall in the bad lands or did it fall over here in the safe zone? And since it fell in the safe zone, we are not going to reject the null. But somehow you got to have you a sentence. So under our decision, since it falls into the non-critical region, then the decision is to not reject the null hypothesis. And you're going to need to make a statement on the test. You'll need to say, we will not reject the null hypothesis because our test value, you can say, does not fall in the critical region, or it falls into the non-critical region, you need to make a declaration. You can say, because our value falls into the non-critical region, we decide we will not reject the null hypothesis. Get you a little canned statement there, and it would probably even be a good idea to write your little canned statement over here on your formula sheet. Decision, what's going to be my canned statement? I reject, I don't reject, because it falls into, because it doesn't fall into, critical, not critical. What are you going to use? And use it every time based on the evidence. And so back over here, we found the hypotheses, we found the claim, we found the critical value based on 0.10 in our chart. We did the test value, we calculated Z. We made a decision. Are we going to reject or not reject? Since we weren't in the critical, we're not going to reject. We have one last thing to do, and we need to make a conclusion, and it's a conclusion sentence. And the conclusion sentence is going to be where you come right over here, not to the book and the test, but you'll have this written on your card. And when you come over here from your card, you've got to remember that our claim was the alternative hypothesis. So since our claim was the alternative hypothesis, this is our claim, one of these is our final answer. Now, did we reject the null or did we not reject? We did not reject it because our Z value fell in the non-critical region, and so this is the statement we're going to use for our conclusion, but we have to add in some more pieces and parts that are relative, that are critical to the question that we were working on. So when I turn back over to that question, you're going to see words like, there is not enough evidence to support the claim, and then we need to fill in the blanks. What was the claim? So coming right back over here, notice they're written, and you can just keep repeating the same kind of stuff over and over and over and over. It's going to be one of those 4 squares. There is not enough evidence to support the claim, and then you got to fill in the blank. That the students scored below the national average. Done. We finished one. And now I want to do a second one. You really might want to hit pause and go back and process and think and redo and maybe even hide all of your notes and try to do this problem from start to finish by yourself. Like start right here. You might want to fudge and go ahead and get this X bar, because I would never give you 36 numbers on a test. I might give you 10. And then I would have to tell you it's normally distributed. We're going to try to do another one and me keep the video short. It's not looking too good. So down here at example 8-5 is on page 422. The cost of rehab. The Medical Rehab Education Foundation reports the average cost of a rehabilitation for stroke victims is average cost. Average is going to be our X bar. So if you want to go ahead, do some circling, go ahead and put that as your X bar. But you know, is it the X bar or is it the mu? It's an average. Is it national? Looks like this one's national. Let's see if it checks out. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample. Okay, here's our random sample. We think that's N. Of stroke victims in a hospital and finds that the average cost of their, the average cost of theirs, here we go with X bar. There's the average cost of the sample. So this one wins. It is mu. The standard deviation, oh nice. The standard deviation for the population, joy, oh joy. We get our sigma. And then add an alpha of 0.01. We already know what to go do on that. Can it be concluded the average cost of stroke rehabilitation in a particular hospital is different? Different. Not higher, not lower, is different. And that's going to scream at us. We're going to do a two-tailed. So here we go on those 5 steps. Step number 1. We need to do the hypotheses and the claim. So here we go. I don't know what word that is. The null hypothesis, we're saying our mu is, that does not look like an is the $24,672. It's always going to be the equal one. But we're saying that our our alternative, our H1, or sometimes it'll be H sub A, our alternative hypothesis, is mu ain't that. And if it ain't that, it can be higher or lower, but it is not the 24,672. And that is our claim. They are looking to see if this particular hospital is different. Different is not the same. Different is this one. So we have to designate this is our claim. Moving on down the steps, after we do hypothesis and claim, we need to go find the critical value. For the critical value, we're looking at an alpha of 0.01. I haven't drawn a picture, but hopefully as you see the do not equal, you see that we are going to have a two-tail. We're going to have a critical region on the left and a critical region on the right. So we're going to go grab our table F. And when we grab table F, I am looking for two-tail. And when I'm looking for two-tail, I'm looking for the 0.01. When I scroll all the way down to the bottom, I get that it's 2.58. And if you join with me up here at the top of the next page, which is 423, you see our hypotheses, our claim, and our 2.58, which one has to be on the left and one has to be on the right. I'm going to go ahead and use their drawings. I'm going to hide this little thing that happens right over here. And I'm going to use their drawing. Well, I've got my drawing going too. I need to hide that too. But looking at the drawing, do you see how we have the negative critical value? And we have the positive critical value. And we have the Badlands and the Badlands. And we have the safe zone here in the middle. After we calculate, find the critical value, it says let's go find test value. Test value is Z. So to go find Z, I've got to pull some pieces and parts out of this problem. And so to go find Z, I need to go back to that X bar. X bar is the number, oops, where am I? X bar is down here, where they are saying they think this hospital is 26343. So we plug in the, you can either look at mine or theirs, the 26343 minus, let's go grab mu. Mu's already up here at the 24,672, divide by, where did this 3251 come from? Well, over here we found that our sigma, our population standard deviation, is 3251. So we're going to put it in here. We're going to do square root of our n, which way back over here we saw that the n is 35. We're going to go punch, punch, punch in the calculator. This time they went 3.04 and I went the long route. Either way we go, looks like we're getting a positive 3.04, positive 3.04. So we need to put it wherever it is. Remember, 0 is in the middle, and 3.04 is beyond my critical value. An alarm should be going off on theirs too. It's beyond this critical value. And since it's in the Badlands and the no man's land, anyway, it's a bad place to be. We computed the test value, now we've got to make a decision. And with us falling into the Badlands over here, we have to reject the null. And so you got to have some sentences, and I mentioned you might want to write this down. And so here's a good sentence. We will reject the null hypothesis, and you need to tell me why. Because the test value falls in the critical region. Please don't use Badlands. Please use the word critical region. You could even say it opposite. We're not going to reject, sorry. We better leave it alone right there. I'm just going to leave it right there. We do reject it because it falls into the critical region, which is beyond the critical value. The last thing, and I'm already at 24 minutes on this video. Yikes. We are going to need to make a final decision. Do we reject or not reject the null? Now I'm really rushing. That is what we just did. Because we're in the critical Badlands, we are rejecting the null hypothesis. Now because of that, we've got to summarize the results, and we need two things. We need that our alternative was the claim, and we need to know that we fell in, where are we? I'm jumping around. Our alternative hypothesis is the claim, and that we are rejecting the null. So I'm going to scoot on over here to page 417. Our claim, again, was the alternative, And did we reject the null or not reject? We did reject the null. Since we rejected the null, that means we got one statement to write. The one statement is there is enough evidence to support the claim that, and here's where we have to fill in the blanks, to support the claim that, there is enough evidence to support the claim that the average cost of rehabilitation of this particular hospital is different. We can't say it's more or less. We have to say it is different from the $24,672. I need to end this video. You all hang in there and then go back and even try to do example 8.5 by yourself without notes.